Alright, today we're going to talk about 9-6, tessellations. Objectives: use transformations to draw tessellations, identify regular and semi-regular tessellations, and figures that will tessellate. Tomorrow in class, y'all are going to do a tessellation. Alright, a pattern has translation symmetry if it can be translated along a vector so that the image coincides with the pre-image. A frieze pattern is a pattern that has translation symmetry along a line. Okay, both of these figures are frieze patterns. The pattern on the right, this one right here, also has glide reflection symmetry. Glide reflection symmetry coincides with its image after a glide reflection. Okay? So see how this one's kind of gliding? Alright, helpful hint. When you are given a frieze pattern, you may assume that the pattern continues forever in both directions. So it never stops, it keeps going on and on. Identify the symmetry in each wallpaper border pattern. Okay, so how do we get from here to here to here? It's translation. Let's see if I got that on there. I do. Translation symmetry. That is a slide. What about B with the paw prints? Okay, it's a slide, however, it's a translation, which is a slide, but it's also a glide reflection symmetry, okay? A glide is where you have two. A tessellation or tiling is a repeated pattern that completely covers a plane with no gaps or overlaps. The measures of the angles that meet at each vertex must add up to 360 degrees. Okay, so in the tessellation shown, each angle of the quadrilateral occurs once at each vertex. So let's just look at this quadrilateral right here. We've got each vertex. They're different colors, okay? Because the angle measures of any quadrilateral add up to 360 degrees, any quadrilateral can be used to tessellate the plane. 4 copies of the quadrilateral meet at each vertex. So if you look right here, and you have the blue, green, yellow, and red angles, it makes a complete circle. Therefore, 360 degrees, you know that it will tessellate. A regular tessellation is formed by congruent regular polygons. A semi-regular tessellation is formed by 2 or more different regular polygons, with the same number of each polygon occurring in the same order at every vertex. Okay, so wow, I already gave you the answer on that one. That is regular. Remember, regular is formed by congruent regular polygons. This is semi-irregular because you have more than one shape. We actually have 2 different shapes here. They're just color different, the triangles. Every vertex has 2 squares and 3 triangles in this order. Square, triangle, triangle. Okay, so that's just describing why it's semi-regular tessellation. Okay, classifies tessellation as regular, semi-regular, or neither. Okay, what about this first one here? It is not regular. It is a tessellation, but is it a regular or semi-regular? No, it's not regular because the polygons are not regular or semi-regular. Because you have irregular polygons here. Okay, what about the second one there? You have regular polygons. You have one shape, so it is a regular tessellation. And then what about that last one? You have a hexagon, and it meets 2 squares and a triangle at each vertex. So it is a semi-irregular. Alright, what about this one? You have only hexagons, so it is regular. Hexagons are a regular polygon. Okay, now we're going to determine whether the given regular polygons, they're telling you they're regular, can be used to form a tessellation. If so, draw the tessellation. All right, we are not going to draw the tessellation because y'all are going to do something like that in class. Okay, so we have a regular polygon here. Okay, so you could rotate it. Whoops, excuse me. You could take the measures of the angles. Okay, so the measure of each angle here, if it's regular, is 60 degrees. And I get 6. So this is yes. All right, what about B over there? This one is no. Okay, these angle measures are 108. These angle measures are 60. So is there any way you can take 108 times something plus 60 times something and get 360? And the answer is no. Didn't know that was on there. Let's see what it says. Okay. Okay, what about A here? Again, you have a hexagon. So each angle is 120 degrees. So if you take 360 and divide by 120, you get 3. So this is yes. And then what about B over there? Okay, you have no on this one. Right here you would have, what is that? 90 times something plus 120 times something equal 360. And you can't do that to have a positive P and M, so your answer there is no. And that's it, guys.